Greetings everyone. We are Team Libra from K2T4B at College Matrikulasi Sarawak. This is our team member, Ashley Lin Yishen, Janelle Yong Jiarong, and Jonathan Tay Liang Yao. Under the guidance of our lecturer, Sir Muhammad Hafizuddin bin Kamaruddin, we are treated to present our innovation learning project, Escape the Scout RPG. Let's talk about a major challenge in pre-university biology. Traditional biology study often leaves students feeling overwhelmed by static tests, lengthy notes, and a weak comprehension grasp, which unfortunately leads to almost zero long-term memorization. We developed Escape the Cell RPG to directly solve this problem by transforming complex science into an interactive, immersive adventure. Moving on to our selected biology topic, Escape the Cell RPG is specifically aligned with the SP015 Biology 1 syllabus under Chapter 1 Molecule of Life, focusing on DNA and RNA. Our learning scope covered the core theoretical foundation students must grasp, explaining the structure of DNA and RNA, understanding the protein synthesis process, and correctly pairing up nitrogenous base between nucleotides. To make this abstract concept tangible, our game translates this scope into focus in-game mechanics. Players actively participate by repairing damaged DNA, transcribing mRNA, translating amino acids, and ultimately synthesizing a fully functional protein to progress through the game. Our main learning objective aims to replace boring rote memorization with an engaging game-based experience. First, students will master the structural difference between DNA and RNA, including their base component and complementary base pairing rules. Second, students will understand the step-by-step mechanism of DNA replication, transcription, and translation, and protein synthesis through active gameplay. Finally, the platform works to upgrade student critical thinking and problem-solving skill in molecular biology.
Now let's take a look at how Escape the Cell RPG works. Our game is a self-directed web-based platform using board.new platform, making it accessible on laptops, tablets, and mobile devices. Players control Agent Bio using WASD keys on the computer or a touch joystick on mobile devices to explore the 2D cell environment. Our project emphasizes on 3 sustainable development goals. First, SDG 4, quality education, by transforming complex biology topics into an interactive RPG, making learning more engaging and effective. Secondly, SDG 9, industry, innovation, and infrastructure, as we integrate digital technology and gamification into biology education through a web-based learning platform. Finally, SDG 3, good health and well-being, by strengthening students' understanding of molecular biology, which forms the foundation for genetics, biotechnology, and future healthcare studies. The adventure begins with a short introduction that explains the storyline and the player's mission. Players then interact with Dr. Saito, the main NPC, to receive instruction and learn about the protein synthesis pathway. To help players navigate efficiently, a tracking line is displayed on the screen, guiding them towards the next mission objective. After reading the NPC dialogue, the mission panel appears, showing the tasks that need to be completed. Players explore different organelles, interact with NPCs, and solve biology-based puzzles and questions to unlock new pathways. If an incorrect answer is selected, the players are required to read the dialogue with the NPC again and find the correct answer, allowing players to understand their mistakes before trying again. Once all missions have been completed and every NPC interaction has been finished, players can finally escape the cell, and that is the end of the game.
Escape the Cell RPG transforms students from passive learners into active problem solvers. Instead of simply reading notes and memorizing biological processes, students learn by exploring a virtual cell and completing interactive missions. Throughout the game, players answer biology questions and solve puzzles related to protein synthesis. If an incorrect answer is selected, immediate feedback is provided, allowing students to understand their mistake before trying again. This active learning approach keeps students engaged while strengthening their understanding and long-term retention of complex biology concepts. determine whether this learning approach is effective, we compare the learning performance of a control group and an experimental group using pre-test and post-test results. The findings show that the experimental group achieved 2.57 times greater improvement than the control group. In addition, 3 students obtained a perfect score of 100% in the post-test after using Escape the Cell RPG. These results demonstrate that our innovation effectively improves students' understanding of DNA and RNA while making the learning experience more engaging and enjoyable. In conclusion, Escape the Cell RPG combines biology with interactive gameplay to create a more engaging and meaningful learning experience by encouraging students to learn through exploration, problem solving, and immediate feedback. Our innovation helps them understand protein synthesis more effectively than traditional learning methods. We hope Escape the Cell RPG can inspire a more enjoyable and effective way of learning biology. Thank you for watching.